Hello, my name is Serge. I'm the sales director for DeepSpar. I've been the one doing most of our sales and marketing for, I guess, 17, 18 years now. I decided to make this informal video where I go over some of the common questions that people have been asking me for years. And I also wanted to go over, I guess, the overall state of the data recovery industry. So just in terms of how recoverable solid state drives are, hard drives, removable flash storage devices, and where we appear to be heading in the future, at least from where I'm sitting. So this will be quite a long video because I really want to cover this in detail and explain how I've come to the conclusions that I've come to. So let's get started. So of course, the number one question that people have for me is what tools they should buy for their data recovery business. So so this question is kind of complicated. So unfortunately, only the person asking the question could answer it. And to answer it, you first have to understand the kinds of problems that exist in storage devices and the kinds of tools exist to solve them. So as you may have seen in many of our other videos, we basically separate all issues into three distinct areas. So level one would be the data level issue or the logical issue. So that's where there's just a problem with something with the software side of things, where the storage device is still healthy, but maybe the user accidentally deleted some files or reformatted their drive, or maybe they had a virus attack, something like that. And these issues are solved by data recovery software or logical recovery software, like RStudio, and there's many of them out there. So at this level, there's no real benefit to having hardware tools. You just need a software tool that can analyze the data and find everything that still exists on this drive. So this is a relatively straightforward task. Mostly it's just pressing, one button in the software, and then you wait, and then you see what it shows you. So there's not much to this. Pretty much everybody does these kinds of recoveries. The next step up from that would be level two, which is disk level issue, which is also called read instability issues. So that's where the storage device has started to fail, but it hasn't crashed completely yet. So this is drives that have a lot of bad sectors, drives that hang once in a while. They might respond to some commands with errors, but as a whole, they're still generally reading and identifying just very poorly, very slowly with some problems. So this is handled by read instability handling hardware, which is primarily what we focus on as a company. So tools like USB Stabilizer, RapidSpar, DeepSpar Disk Imager, they're primarily built to handle read instability issues. And then the third type of problem is a drive level issue or complete drive failure. So that's where the storage device has crashed completely. It is no longer able to read anything whatsoever. Maybe it can't identify, or it identifies incorrectly and can't process any read commands. Anything like that is a drive level issue. So these are the cases that you have to do some kind of repair to move forward. So it could be a physical repair, which is by far the most common. So you might have to swap the read-write heads, or clean the platters, or clean the heads. You have to do something with the mechanics. So you have to open up the drive in a class 100 clean air workstation, and you have to do something to it in most cases. Then you could have total drive failure due to electronic problems. So if the circuit board is fried, then typically what you'll have is the drive that makes no noises whatsoever when you power it on. So you power it on and it's just dead silence. So that's usually an electronic issue. And this is solved by swapping the circuit board. So you have to buy the same circuit board and then swap them, and typically you have to carry over some unique firmware from the original board to the donor board. And then the third type of problem that can cause complete drive failure is firmware corruption. So drives have quite a large firmware subsystem, and if it fails in a significant enough of a way, the drive could become completely unresponsive to a normal computer. So generally, drives will also have every issue of a lower level, meaning when you have a drive with a read instability issue, you will generally be dealing with a logical issue as well on top of that, because if there are bad sectors, then some parts of the drive will be unreadable, and the logical structure is likely to be corrupt as a result of this. So when you have an unstable drive, you have to deal with both read instability issues and logical corruption. And same way when you're dealing with complete drive failure, usually you have to deal with all three levels, because after you repair the original problem that is making the drive failed, you will usually be dealing with read instabilities and then logical corruption. So you need to handle all three types of issues if you want to handle complete drive failure. So very, very common question from people is, just tell me what recovery rate I will have with some particular tools and I will buy them. People who don't want to really understand too much about data recovery, they're just looking for a shortcut. Unfortunately, this answer, this question cannot be answered. It's impossible, because the number one reason that affects recovery rate, particularly when it comes to simpler read instability handling tools, is the types of cases essentially that the user will get, or in other words, the number of previous recovery rates that their drives will be subjected to before the drive reaches them. So you could have very, very easily one person using one particular tool can have a 90% recovery rate, and then another person using exactly the same tool, exactly the same process, can have a 20% recovery rate. And this is really how large the difference is between the experiences of different people, simply because they're dealing with completely different cases. It's very simple for a technician who is just using logical software and pressing one button to have a higher recovery rate than the best data recovery company in the world, simply because they deal with different cases entirely. So the number one factor that determines how difficult your caseload is going to be is it's almost like the socioeconomic status of your average customer, or in other words, how much money your average customer has relative to the price of data recovery. Because if the price of data recovery is a lot of money to them, then they will be highly motivated to avoid paying the price, which means that they will go on the internet, they will download free data recovery software, they will follow various questionable data recovery guides, they will try this for days, and then they fail, they'll give it to some friend who is good with computers who will do exactly the same thing. So they will be trying at it for days and days and days, and one of two things will happen at that point. So either they get lucky, in which case they do their own recovery, so they don't need services anymore, or they will get unlucky, in which case they will destroy their drive to the level where mechanical repair is the only possibility where something can be done. So if this is the kind of case flow you will have, where drives have gone through many prior recovery attempts, then you'll be dealing primarily with completely mechanically destroyed drives, and you need the most professional tools, which I'll talk about later. On the other hand, if you can get to drives early on during the failure process, so this is generally shops in wealthier areas of the world, they will have customers bring them their drives or bring them their computers as soon as the computer has the first signs of problems, like when it's just slowing down or failing to boot. These shops will have largely just read instability issues or logical corruption, because their drives will not be at a point where they're completely failed. And those are the kinds of shops who will have 90% recovery rate just with read instability handling tools. And the other end of the spectrum is, of course, poorer areas of the world, and they will have primarily mechanically failed drives. So the number one, in order to figure out what tools you should get, first you have to figure out what kinds of problems you will have primarily, because really everything depends on that. Because if you will have primarily drives that are completely failed, then you need professional tools. So the number one tool you need is it's called PC3000. So there's really no substitute for this product. It's far and away the most advanced and the most expensive data recovery tool in the world. There's really, you have to get this one if you want to deal with complex cases. And of course you need various supporting equipment. Like you don't need a class 100 clean room, but you need something that gives you class 100 clean air, which is generally done by setting up a laminar flow station. There is many vendors who sell pre-built products for about $2,000-$3,000, something like that. So you can buy like a laminar flow station, and that's perfectly fine to open up hard drives in, as long as the air inside is clean up to the class 100 standard. And as an alternative, a lot of people build their own, because ultimately it's a plexiglass box with two air filters. So you have a HEPA air filter and a pre-filter and some fans. It's a relatively simple design. So a lot of people just build their own because it's a few $100s of parts. But yeah, you do have to read up on it a little bit to get the proper filters that will do the job. And of course you need various supporting equipment, like you need headcoms, you need a good microscope, you need various cleaning solvents, little things. But overall, if you're going to do data recovery at that level, you will be looking at more than 10,000 US dollars as a total investment, and you will need to spend several months at least learning the subject. So data recovery, it's not really rocket science. In fact, even having formal education doesn't really help with data recovery in most cases. Of course, it helps with some things, but generally you don't need a formal education to do data recovery. What it is, it's mostly about practice. So there's the complexity in it is that there's a lot of different drives, there's a lot of different cases, a lot of different problems that these drives can have. And what learning is it's basically getting these problems and figuring out how to solve them. So especially if you buy PC3000, you'll have a very, very large resource. So you'll have several hundred pages of user manuals, and you'll have access to closed forums from Ace Laboratory, where you can get access to many thousands of posts, kind of questions and answers, and you can get a lot of information there. So learning is mostly about getting some practice drives and then trying to recover them, going through those resources, figuring out how to recover them. And once you do it once, you learn how to do it. Then it's very easy after you do it once. And kind of same thing with mechanical repairs. You have to do it a number of times, and before you get down kind of the muscle memory, and you make all of the simple mistakes that absolutely everybody makes. Everybody destroys many drives while learning, so you should definitely not be learning on your customers' drives, because if you're just opening drive for the first time, almost certainly you will destroy it, like 90-something% chance. So you have to be working on some unimportant drives, making your mistakes, and then once you make your mistakes and you figure out how You kind of get comfortable with it, and then you can start working on customers' drives. So generally, it's several months of practice, but of course, there's a large difference from person to person. Everybody learns at different rates. So for some people, it's 3 months. For some people, it's 12 months. Everyone is different. So on the other hand, if you don't want to do data recovery to that extent, so for example, if you don't have enough cases to justify spending so much time and money on equipment, then you should just be looking at read instability handling tools and logical corruption tools. So for basically levels 2 and 3, and you should find a good partner to outsource to, because of course you will have cases that are completely dead, and you can still make some money on that because everybody will give you a commission, some sort of rate, 10 to 20%. 10% is pretty weak, 20% is pretty good, and so you can still make some money on doing this. You just have to set up a partnership with some sort of established data recovery company. Any of them will be very happy to talk to you about this. This is how they get a large part of their revenue, and they usually have specialized people who handle that kind of thing. So they will have some sort of agent for you to speak to, and you can set something up. One major kind of aspect that more people should probably consider is the price of data recovery, because large companies, they might give you better terms or better rates, but if they charge $2,000 or up for an average case, that's a lot of money, and a lot of your customers will of course not proceed with that. There are quite a few very competent companies that will charge $1,000 average for an average mechanically damaged drive. You should probably look for one of those. Of course, I'm not saying that $2,000 is not a legitimate price. Like, it all depends on the case. There are definitely cases where $2,000 is a very, very fair price, because, for example, some drives will have platter damage, and in order to recover them, the person doing the recovery might have to buy multiple donor drives. So they buy a drive, they swap the heads, they will be able to read some percentage of the drive, and then the platter damage will destroy the new set of heads. And then they have to buy another donor drive, and each donor drive, is a couple $100. And they might have to do this multiple times, and they might have to spend tens of hours doing these endless head swaps, and it could be legitimately multiple thousands of dollars to do a drive that's completely failed. But generally, your median drive just takes one head swap, and then you're done, in which case the price should be very, very roughly about $1,000. So it's if you're paying $2,000 for a median drive, you're probably overpaying for your data recovery, and maybe consider looking for another company. Please do not contact me and ask me who to send drives to, because I will not respond. Pretty much every single data recovery company is a customer of ours, and our strategy has always been to remain neutral. So I will not tell you that somebody is good or somebody is bad. This is just not something that we do. So it's something you have to research by yourself. So in terms of read instability handling tools, so by far the number one read instability handling tool in the world right now is our USB stabilizer. So this is far and away the most popular product we've ever built. I'm probably going to make a separate video where I go into it in detail, sort of like a training / video user manual for it, where I will go through it in a lot of detail. But basically what it is, it's a little USB device that you connect storage devices to your computer through. So you connect your drive to this device, and then this device to the computer. What this device is it's basically an ARM processor and a kernel driver. So what this processor does is it pretends to be the storage device to Windows. So you connect a drive to this device. We identify the drive, and then the ARM processor takes on the identification parameters of the drive, and then it identifies as the drive to Windows. So this way, it's not a direct connection from your software tool, but the connection goes through us. And what we're doing is we're basically filtering out all of the situations which would normally cause Windows to do something bad, like drop the drive or blue screen or just refuse to identify the drive. So we basically figured out all of these situations, and then we figured out how to substitute them with something else that Windows considers to be harmless. And because the connection is not direct, this also allowed us to do resets and repowers. Like when this unstable storage device inevitably starts hanging because it's stuck doing something like internal read retries, and which is damaging, of course, we can cut that off using resets or repowers, and your software will not be aware that the device has actually been reset or repowered because it's actually working with the ARM processor, which is of course not losing the connection while this is happening. So this gives us a lot of control to sort of handle read instability issues, and that's what this product does. This is really this is the number one tool these days because of well, for a few different reasons. So number one is it's by far the least expensive read instability handling tool in the world, including Chinese tools. So it's the cheapest tool primarily because of the architecture that we're using. So it's a completely unique product. Nobody has ever built anything even similar to it before. There were numerous products that offered similar functionality, but they were developed by essentially building small computers. And what they would do is they would do the whole reading process inside of this small computer. And after the data was retrieved, then they would give it to Windows. So the upside of doing this is that it's many times easier to develop a product like that because you don't really have to learn about Windows. You don't have to know how Windows works. You just build your own, some sort of custom environment, and you simply read the drive, and you don't have to worry about anything really. You build your computer and you go. The downside of this kind of design is the manufacturing cost, because if you have to build a full computer, of course it's quite expensive for you to manufacture. And these days, in the post-pandemic world, the manufacturing costs are so high that if you build a product like that, you pretty much have to sell it for more than $2,000, just because of how much you're going to be paying to manufacture it. So USB stabilizer is kind of in the middle between an adapter and a computer. So most of the actual logic is handled inside of the kernel driver, and it is extremely difficult to build this driver because basically you have to do a very large amount of research on Windows. All of this is of course unpublished. Windows has almost like an internal, it's like artificial intelligence that it uses, which it, and that's how it decides when it's gonna drop a drive, when it's gonna refuse to work with the drive. And you basically have to do years of research to figure out all of these situations, because it's not as simple as, oh, the storage device has a certain error, so Windows will drop it. There are situations like that, but most of the issues happen not because of some specific event, but because of a series of events that have to happen at the same time. So the device has to be slow to respond, and then it has to give certain errors a certain number of times, and then Windows will do something bad to it. So it's basically years of research to figure out how Windows works, and then manually find ways to get around all of these problems. So this is why it's a completely unique product. Like, nobody has taken on such a big development job before. When we released it, most of the vendors, they bought one, and they even started writing on social media how they're gonna release a product just like it, and then they actually looked into it and they calmed down and they realized that they can't build the same thing. It's far too difficult, and this is why stabilizer is a unique product. It's too hard to build a device like this, and we had to focus very heavily on it just to come up with a working device. So instead of 2,000 plus dollars, we have different options between about $300 to $1,400, and I'll go through the different editions of the product when I make the video that's specific to the stabilizer. But the second reason, aside from the price, that it's the most popular tool is because of how flexible it is. Because the emulated drive shows up in Windows as if it was connected directly, you can use any software to work with it. So you're not limited to using some particular piece of software, and you can always use the best software tool for the job, for the type of problem or logical problem that the drive has, which is very convenient. You don't even really have to learn very much. You can just keep using whatever software you're already using and just add our hardware to the mix, and it will be pretty seamless and pretty easy. So that's definitely the first tool. Like if what you're looking to handle is read instability issues, that should be the first tool. It's very kind of straightforward that this is the first tool to get. You may also get other tools after that, after the USB stabilizer, like possibly our RapidSpar, but the decision on that should definitely come after you get the stabilizer, because you might just be fine with just the stabilizer itself. So the main reason to get RapidSpar is that if you have a lot of SATA hard drives, so with the USB stabilizer, you can work with SATA drives using an adapter. Like that's the beauty of USB interface, is that you can use practically any interface with it, because USB, of course, is the #1 computer peripheral interface, and whatever storage devices, storage ports exist, there is an adapter that converts them to USB practically for every single port out there that exists or will exist in the future. There's going to be an adapter for it. So you can connect it through the USB stabilizer using an adapter. So it's very universal in that way. The problem with adapters, especially for SATA drives, is that these adapters, they essentially harm the read instability handling process. So for SATA drives, what that does is that does two major things. So one is, in a few cases, it won't be a lot of cases, a few % of cases, the drive may fail to be identified by the adapter itself, in which case a tool like USB stabilizer fundamentally cannot do anything, because the problem is on the adapter level. The adapter may decide that it doesn't want to work with the storage device anymore, maybe because it's slow to initialize, or maybe because it responded to some initialization command with some error, and then the adapter will just refuse to work with it. This won't happen a lot. It'll be a few % of cases, but it will happen sometimes. So that's one of the two reasons why adapters can hurt. But the #1 reason why adapters are problematic is the fact that it slows down the speed of error handling. So with SATA drives, you can use much better resets than PHY reset. So for USB, there's only PHY reset. That's the only thing that works well. So PHY reset is where you're like physically reconnecting the USB port, the USB channel. And for SATA drives, well, there's a lot of resets in SATA drives that you can do natively that are 2 to 3 times faster to process than USB PHY reset. It's a huge difference, so 2 to 3 times. And so that means that you can handle SATA drives with a lot more bad sectors and a lot more errors if you're using native SATA tools like RapidSpar or any other native SATA tool than using USB stabilizer with a SATA to USB adapter. But of course, still you can do the majority of unstable drives with USB stabilizer using an adapter. So this is why, like, generally this is the first tool you should get, and then you can see, and then you see what recovery rate you will have, and it'll be a lot more clear whether it makes sense for you to buy other tools or not to improve your native SATA hard drive recovery rate. So like I said, I'll go over USB stabilizer in a separate video in more detail. It's a #1 tool these days. And if you have very few cases, like if you're dealing with data recovery a few times per year, then it's not even going to make sense for you to get USB stabilizer. You should just be looking at logical recovery software by itself, something like RStudio or many others. They have relatively inexpensive options, and that's probably what you should get if data recovery is something you do a few times a year, because no hardware will pay for itself if it's that rare. So one common question that people ask me is what about flash storage devices, solid state drives, removable flash, things like that. So solid state drives, they have all three levels of recoveries, like all three types of issues, same way as hard drives. So they have logical issues, they have read instability issues, and they have complete drive failure. However, at all three levels, solid state drives are substantially less recoverable than spinning drives. So for logical issues, they are less recoverable because of trim. So there's a so-called trim command that Windows and other operating systems will send to a solid state drive when a file is deleted from it. And what that command does is it basically erases those files permanently. So on a spinning hard drive, when you delete a file, it remains on the drive, and just a file system entry gets changed to mark that space as available for future use, and the operating system will only overwrite that space when it's writing new files to the drive, basically when it has a need to store more data on this drive. So your old files can remain on the drive for a very long time after they're deleted. So this is not the case for flash storage, because flash storage can't simply write on top of old data. It has to actually erase the cells first, and then it can write to them. So in order to make writing faster, what they came up with is the trim command, which means that the solid state drive can erase cells whenever it has idle time, and when it has to write data, it already has empty cells as available, so it's much faster. So this is why trim was implemented. So it's awful for data recovery, because what this means is that when you delete files on an SSD, usually they're gone forever. The data stops existing. There's nothing that anybody can do to recover it. Of course, there are other logical issues, various operating system bugs, viruses, well, some types of viruses, that will still be recoverable, but it's a smaller percentage than in hard drives. In terms of read instability issues, so solid state drives have the same kinds of problems. They have bad sectors, they hang once in a while, things like that, but there's a lot less of those types of issues. The main reason why there are less read instability issues is because there is a much smaller window of opportunity to get the data before the solid state drive suffers complete failure. So for mechanical drives, you typically have days to weeks to get the data after the hard drive develops bad sectors or other read instability issues. But for solid state drives, you only have from hours to days. So it's many times shorter window of opportunity to get the data after the drive becomes unstable. So what this means is that in most cases, the solid state drive suffers a complete failure before the drive goes out for data recovery services. So while the user themselves is still figuring out what's happening, what's wrong with their drive, or they're sending it to somebody else who has to diagnose the system, and they take that SSD and they're plugging it into various adapters and trying to understand what's happening. So while all of this is going on, the SSD fails because of how short the window of opportunity is to get the data. And after the SSD fails completely, there's also a much smaller recovery rate, because in most cases what fails is the flash itself. So the flash memory becomes degraded, and basically cells lose charge and the data stops existing. So nobody can do anything in the majority of cases. So in terms of recovery rate, right now, companies that have every single tool in the world that are doing everything possible have about 30% recovery rate for PCI Express SSDs, and a bit more for SATA SSDs. Not a lot more though, maybe 35-40%, something like that. So nobody can do better than that, and it's never really going to improve from this. In fact, it might decrease a little bit more. I can explain how I know this. That'll probably be interesting to some people. So we've done a lot of work on PCI Express SSDs, a lot of work. So back in 2015, when the first widely used NVMe SSD, M2 NVMe SSD started coming out, and vendors started putting them into laptops, all kinds of computers, and they were started to be used very widely. We started to develop tools for NVMe SSDs. And the first tool we were working on is called the PCI Express SSD add-on for DeepSpar Disk Imager. So this was the first PCI Express SSD tool in the world by a couple of years. So back when we were developing it, there were no tools whatsoever. So everybody was just using different Linux software and watchdog timers that they used to reboot the whole system every time that it would freeze. And because there were no alternatives, pretty much almost every large data recovery company was working with us. So what we did is we set up remote systems for them. So for every single PCI Express case they would get, first they would try it on their Linux system, and when it failed, they would connect it to our remote system, and we would work on their cases remotely. So we got a very good statistics from that, because we had thousands and thousands of cases over the 2 years or so when we were developing the add-on. And we learned that the recovery rate, when you just have read instability handling tool, is about 20%. So 19.7% was the total recovery rate. So about 20% can be done. So that's that's not so good. Of course, it's quite low, but it is pretty steady as well. So for the last I guess about 5 years or so, we saw this rate as being pretty steady. So about 20% of PCI Express SSDs have read instability handling tools, read instability handling issues, and this rate is staying pretty steady year to year. And another tool that we spent a long time working on is a drive repair tool for NVMe SSDs. So we took the first widely used NVMe SSD, and basically we tried to write custom firmware for it, which would be more flexible in terms of issues and will allow us to recover a larger percentage of these SSDs. So what we did is we basically hired a bunch of people. So we put up forum posts and ads for experienced engineers, and we interviewed hundreds of people, and we hired it was roughly 10 teams of 1 to 3 individuals per team. It was people working from all over the world, and we had one person here in Canada at our office who was basically running around and helping these people, connecting SSDs, soldering things, whatever they needed. And these people worked for us for about 7 or 8 months, and the end result was that 8 of these teams accomplished absolutely nothing, so they couldn't figure out anything about that SSD. One team got part of the way through. Basically, they were able to read decrypted data from the flash memory, but they did not figure out the translation tables. Basically, they were halfway done. And one team of 2 people fully completed the task. So they went in through the JTAG port, and they were able to load their own firmware onto the SSD and then read data through the JTAG port. So we got this first solution, and then we started actually trying it to see how effective this would be. So for this, we had a lot less statistics, so nowhere near thousands of cases, because a lot less companies were okay with sending their drives to Canada, because it was one thing for us to work remotely on cases, but it's something else completely for them to send their drive overseas to Canada and have somebody solder stuff to it. So we had a lot less cases to get statistics. So these statistics are definitely a lot less accurate than what we have for read instability handling. But our best guess for recovery rate based on the cases that we have is about 35%. So with read instability handling tools, 20%, and with the absolute best tool, the absolute most advanced tool, you could have 35% recovery rate. So that's a pretty poor recovery rate, which is one of the reasons why we didn't proceed to developing a drive repair tool for NVMe SSDs. But that's not even the main reason. So there were two main reasons why we didn't develop a tool like that. So number one is the cost of development. So one of the first things we did after we developed the first solution is we tried to use it on the next firmware revision of the same SSD. So the same model, same processor, just the next firmware revision, which came out about 6 months after the first revision came out. So we took that SSD with the second firmware revision, and we looked at it to see how different it is, to see how much work we would have to do to support it. And we saw that everything is different. So the encryption algorithms were different, everything was different. So in order to support this second firmware revision, we had to do all of this work all over again. And by that point, we already spent, a 6-digit sum of money, like into the hundreds of thousands of dollars, developing that one. And all of this work was ultimately just for one firmware revision of one SSD model. So in order to support most SSDs, an incredible amount of work needs to be done, absolutely incredible, because every firmware revision has to be supported separately. So that's one problem. Just the price, just the cost of development is so high that it's not really possible to make money just by selling a tool like that, because data recovery industry is simply not large enough, and not enough people would buy equipment to justify the multi-million-dollar development cost that such a tool would have. So that's problem number one. So we thought about this for a while, and so it's much easier to make money not by selling tools, but basically by providing data recovery services, by essentially hoarding solutions and then providing services for like $10,000 per SSD, for example. So you can make many times more money doing this than selling tools. It's not even close. So we figured that by doing that, we might be able to make enough money to justify development cost. It's really not clear. It's not obvious. It's quite possible that even doing that, it's not possible to make enough money because of how expensive and difficult it is. But then, okay, so we figured, okay, possibly we could provide very expensive data recovery services and make some money. But then there is a bigger problem. So just the fact that we could only have, out of the 20 or so people that we hired, only 2 of them were able to do the job, and we interviewed hundreds of people. So, there's a very, very small number of people just that exist in the world that are capable of creating this kind of a solution. So just because of how difficult it is, like it's extremely complicated, beyond any explanation, to develop a solution like that. And the people who are capable of accomplishing the task, basically they have to be extremely intelligent people. And this is something that much more than 99% of professional engineers could spend their whole life doing, and they would never accomplish anything. This is how difficult it is. Because you don't really have anything to go on. You have an SSD, and you have to predict very, very accurately how it works. It's you need a very big brain to do this. And we kind of looked at this, and we figured that we simply wouldn't be able to find enough people with sufficient intelligence, even if money wasn't an object somehow, which is very questionable by itself. But even if money was no object somehow, we simply wouldn't be able to find enough competent people to support most SSDs for that level of functionality. So that's what ultimately put an end to any kind of SSD repairs that we were working on. We just found that to be not viable. And of course, we also understood that while recovery rate was 35% back then, I guess that was back in 2017 or so, we understood that it would decrease over time. And this is something that we saw with SATA SSDs as well, because so what are the kinds of cases where this solution works in? Like, when does it work? So it works when the SSD stopped working and the flash memory is still functional. So the SSD firmware basically has crashed, but the flash is still working. So these are the kinds of cases that manufacturers of solid-state drives are extremely interested in solving, because this situation means that the company lost money for no reason. So these are the cases where a few cells have failed and crashed the firmware. So what they need to do is they need to make better firmware, essentially, that would not crash completely when those few cells have failed. And we saw this happen. So early SATA SSDs, they would fail just at the drop of a hat, like they would become just completely unresponsive. And when the first tools came out, which worked by the same principle, basically, they figured out they wrote custom firmware, and they loaded this custom firmware on the SSD that was more flexible in terms of errors and issues. The early tools had more than 50% recovery rate. People were doing 50-60% of SSDs around there, and it has been dropping ever since. It's dropping steadily slowly but surely, because there are less and less of these situations, because manufacturers are figuring out better firmware that um, doesn't fail completely unless the flash memory has failed completely. So this fact kind of resulted in two different trends. So one is less recovery rate overall, because um, we're dealing with more cases with total flash memory failure. So the SSD keeps working until the flash degrades completely, and then nobody can do anything. And that's one trend. And second trend is the increase in the number of read instability issues. Whereas before, as soon as flash got any bad sectors, the firmware would fail and then the SSD would crash. There will be a lot of those cases. Nowadays, the SSD keeps working despite the fact that the flash is degraded. And we get bad sectors, we get random hanging, and this has to be solved by read instability handling tools. So we saw early SSDs had maybe 5% read instability issues, and modern SSDs have about 20% read instability issues. So generally, it's pretty clear that as time goes on, read instabilities will be a larger and larger percentage of everything that's possible to handle with solid-state drives, and there will be less and less drive repair cases. There's still some, about 10% of cases that can be repaired in some way, and 20% can be done by read instability handling tools, and we get about 30% recovery rate. So that's what the best companies have. And it's never going to get better. All we're going to have is slightly increasing percentage of cases with totally failed flash memory, which nobody can do anything with. So the situation with solid state drives and data recovery is pretty poor overall. Quite low recovery rates, and it is what it is, unfortunately, and it is what it's always going to be. So one kind of related question. Everything is pretty poor with solid state drives. What about hard drives? Like, are solid state drives going to replace hard drives? Because there's a lot of these articles coming out for more than a decade now. People saying, oh, solid state drives will replace hard drives in 5 years, or however many years they say, and hard drives are going to become obsolete. So the good news is that this is nonsense. So solid state drives cannot replace hard drives. It's impossible. So anybody who's saying that hard drives are going to become obsolete, they fundamentally misunderstand at least one of these technologies, because it's very clear that solid state drives cannot replace hard drives, and both technologies will be used side by side indefinitely as they're used right now. So there are a few different reasons for this. So one thing these articles usually do is they look at how quickly solid state drives were dropping in price early on, and then they extrapolate this rate into the future. And then they make an assumption that because they will keep dropping in price, there will come a point in time when solid state drives will become cheaper than hard drives per unit of storage. In reality, it's not how it works. You really can't extrapolate like that, because if you look at the main reason why flash memory got so much cheaper in the past is because what they were doing is they were shrinking the size of transistors. So they were basically shrinking the whole circuit down, which allowed them to keep more data into the same amount of semiconductor space, which of course made it much cheaper. The problem with this is that for a few years now, they've made transistors as small as they can possibly be made because of something called electron tunneling. So basically, when you have a dielectric wall separating two electrons, when that wall is too thin, your electrons might just jump over it. No matter what the wall is made of, no matter what, it might just jump over. And this is kind of a hard limit on the size of transistors, because you just can't make them any smaller, and they've reached that limit several years ago. So now they're having to do a lot more complicated things to shrink those circuits further, and it's many times harder. And so this is why we've seen the price of flash storage kind of stagnate for a few years now. So it's still dropping, but much smaller, because it's much harder. And another side effect of these shrinking circuits is that they became less reliable. So essentially, the number of write cycles that the flash memory can survive has gotten to the point where it's so low that it can't be any worse. So at the beginning, flash memory can survive hundreds of thousands of write cycles, and now we're lucky if we have a few hundred write cycles. So it got like 1,000 times worse, and they can't really make it any worse. Like, it's flash is as bad as it can be. So now, in order to drop the price, they have to really innovate. So instead of just doing a trade-off as they were before, so what they were doing is getting cheaper price at the expense of longevity. So they can't do that trade-off anymore. They've tapped out the resource. So now they just have to increase somehow the density of data, or do something else to decrease the price, which is many times harder. And yeah, so that's why the price is hardly decreasing anymore. And it's very clear that flash memory will always be substantially more expensive than hard drives. And one reason you know that this is the case is if you just look at what these manufacturers are doing. You know, the enormous multi-billion-dollar companies that make hard drives and solid-state drives, you could just look at what they're doing, because they are the ones who have, of course, the best understanding of the storage market. They're in it. They spend many billions of dollars researching this stuff. And if they thought that hard drives have any chance of disappearing or being replaced by solid-state drives, then those companies would abandon hard drive development. They would just focus on solid-state drives. And that's not at all what's happening. We can see, they have public reports that they release on this stuff, and it's very clear that they're investing massive amounts of money into hard drive research and development, and they're working very hard to keep improving hard drives, which means that they're certain that hard drives are not going anywhere. So yeah, solid-state drives cannot replace hard drives. They never will. And anybody who has been writing these articles, saying SSDs are going to replace hard drives in 5 years, those guys have absolutely no idea what they're talking about. They're just making stuff up. It really shows their lack of basic understanding of storage industry, and I always laugh when I see these articles. So hard drives and solid-state drives will continue to be used indefinitely. So for solid-state drives, we're seeing them move increasingly towards PCI Express, and hard drives are increasingly moving towards USB. So this is the trend. About removable flash storage. Devices like SD cards and USB flash drives, they are definitely more recoverable than solid-state drives, because solid-state drives, practically all of them are encrypted. What that means is that you can't just take off the flash memory chips and read them directly using specialized hardware. So you have to read them through the controller. There's no other way. Whereas removable flash, for the most part, it's not encrypted. So you're using products that can read the flash directly, which is a lot more successful and a lot easier to do than developing solutions for solid-state drives. So success is definitely possible in a lot more cases. Definitely the majority of removable flash storage devices are still recoverable if you're doing chip-off recoveries. Although the trend is downwards, like with everything else. So there are more and more of those removable flash devices that are encrypted, so you can't do chip-off. So they're essentially becoming closer and closer to being solid state drives with every year. But we're not really there yet. So at this point, still the majority can be recovered if you buy chip-off tools, which are essentially separate tools that have nothing to do with solid state drives or hard drives. They're only for removable flash storage, and it's an entirely different skill set to get as well in comparison with hard drives and solid state drives. Removable flash storage devices also have read instability issues, and pretty much any of them can be connected to USB stabilizer through adapters. However, the rate of read instability issues is quite low, so it's somewhere around 5 to 10%. So they're pretty much at a state where solid state drives used to be about a decade ago. So they have very kind of weak firmware and controllers, and the whole device tends to fail outright due to a few bad flash cells in the wrong place. And then the chip off is the only way. But the trend is with every year they're becoming closer and closer to solid state drives. So of course manufacturers are working on the firmware and it's getting better, and we're seeing a slow but steady increase in read instability issues, and it's pretty clear that far into the future removable flash storage devices will be pretty much the same as solid state drives. So we're going to have more read instability issues, and they're all going to be encrypted, and read instabilities is pretty much everything that's going to be doable for them. Just like solid state drives, there's not going to be much difference. So unfortunately, hard drives are also very slowly becoming less recoverable over time. It's nowhere near as bad as solid state drives, but there is a very clear trend. We do see that less drives are recoverable with all three types of issues again. So for logical issues, hard drives are becoming slightly less recoverable because newer drives have a secondary translator. So basically, when you format a drive, a lot of the newer drives will immediately be filled with zeros as soon as you format them, whereas older drives, formatting didn't really do much. It would erase a small part of the drive at the beginning, and most of your files would still be recoverable even after a format. So newer drives, that's not really the case. They will just immediately get filled with zeros, and you can't really do anything on the logical side of things as a result. So that made newer hard drives a little bit less recoverable on the logical side of things. For read instability handling, hard drives are also a little bit less recoverable because they take further damage faster than they used to in the past. So primarily because data density is getting so high that it takes less physical degradation or less platter damage, less head damage to make the drive completely unreadable. So that combined with increasing capacities of hard drives kind of resulted in the whole data recovery process changing, and this is why the architecture of USB stabilizer is what it is, because like 10-15 years ago, what pretty much everybody was doing is taking full images of every drive. So they would have dedicated imaging tools like our DeepSpar Disk Imager or many others, and for every drive that comes in, they would take a full image, and then they would scan the image using logical recovery software. And that process was just fine when hard drives were small, much smaller than today, and much larger percentage of the drive needed to be recovered, like they were much more full, and they could survive longer than current drives. So these days, that process is completely inappropriate. Just the idea of taking full images, it's been heavily outdated for years now. Unfortunately, some companies still use it, and they lose a bunch of money by using that process. But these days, it's not really viable. So what you have to do is you have to target just the files that you need, because if you try to take a full image, whether it's a hard drive or especially if it's a solid state drive, you're just going to kill the drive in a lot of cases. Like, the drive cannot survive a full image. You have to be much more selective about what you're doing. So this is why the stabilizer is what it is. So it's built to work with any logical recovery software so that you can use the best tool for the job, and you can target just what you need using the relevant software. So this is also why we partnered so closely with RTools technology, with the makers of RStudio. And I'll go into this in a lot of detail in my next video. But basically, having this strong integration between a powerful logical recovery software tool and a powerful read instability handling tool, it unlocks a lot of possibilities that were impossible before, back when imaging was something completely separate from logical reconstruction. So it opens up a lot of possibilities, and we're going to have a lot of things coming that nobody has ever done before. And again, I'll discuss this in the next video when I talk about USB stabilizer and RStudio. So the same trend is kind of happening with drives that are completely failed. So in the sense that less and less of them are recoverable. So for mechanically failed drives, the reason is kind of the same. So it's the increased data density, resulting in less and less platter damage being necessary to make the drive unrecoverable with any tool or method. And there's also more and more unsolvable firmware repair issues, because there is that's actually quite a sharply increasing trend. Like, a lot of newer drives for several years now are just not supported by any firmware repair tool in the world. Once they develop a firmware issue, nobody can really do anything about them. This downward trend started around 2015. So what happened is hard drive manufacturers contacted a number of large data recovery companies, and they told everybody that they wanted to help them do data recovery. And all of the owners of data recovery companies jumped at the opportunity, because of course it would be nice to have help from manufacturers, and they allowed the engineers of these hard drive companies to visit their labs, and they very, very clearly showed them everything that they were doing for data recovery purposes, how all of their tools are working, how everything works. So these engineers, they visited all of the labs, and at the end of this whole thing, when the owners of data recovery companies contacted them for help, they got the reply that, sorry, actually, we're not going to help you. And in fact, we don't like how much reverse engineering is being done in the data recovery industry, and we're going to take steps to prevent you from doing this. So this is when we started getting locked terminals, encrypted firmware, and they started putting up all of these roadblocks to anybody creating any advanced functionality for hard drive repair. So it started to get harder and harder and harder from that point forward. For the first few years, vendors were still figuring out solutions, ways to get around these roadblocks. But now it's gotten to the point where most of the new drives that are coming out are not supported by any tool for firmware repair. And this is not really going to change. So the problem is just that it's becoming too difficult and too expensive to develop tools than the amount of money that can be earned from selling such tools. So unfortunately, we're going to continue seeing the number of unsupported drives increase, and the number of unsolvable firmware issues will continue to increase, unfortunately. I don't see any way that this can change. And this is kind of the reason why we've been seeing more and more large data recovery companies develop in-house capabilities for research and development. So they're hiring engineers and setting up whole departments where they're basically reverse engineering hard drives and figuring out how to solve firmware issues. And this is becoming financially viable kind of because of what I spoke about earlier. Like you can make a lot more money by providing exclusive data recovery services for very large amounts of money in comparison to making tools. So for them, it's economically viable to do this development, whereas for tool makers, it's becoming less and less viable every year. And this is probably going to continue. I know the owners of some of the largest data recovery companies, and they're really spinning up their R&D departments at this point. And there's already quite a significant gap between the capabilities of the largest data recovery companies and the capabilities of medium-sized data recovery companies who have only commercially available tools. Just 10 years ago, this gap was essentially zero. Everybody was only using commercially available tools, and everybody had largely identical capabilities, whether it's a smaller data recovery company or the largest data recovery company. So this isn't really the case anymore. With time, this is only going to get worse. Like, the gap is going to keep growing. There's more and more and more models that companies have in-house solutions for, which the models which are not supported by any tool that you can buy for money. And so unfortunately, that's the trend. So very, very far into the future, 10 plus years, it's looking like what we're going to see is that there will be a few large companies with massive R&D departments who are creating unique solutions that they hoard to themselves, and everybody else will just do read instability issues or logical corruption or simple repairs. So unfortunately, that seems to be where the industry is heading to. So unless medium-sized companies can sort of band together, medium and smaller data recovery companies can band together, they will probably end up going out of business, because it is what we've been seeing quite a lot in the last I guess 7 years or so. But it's it'll be very difficult to arrange something like this. Because you basically have to 10, 20, 30 companies at least would have to come together. They would all have to do some basic development, maybe on one or two particular models, and then everybody would have to trust each other to then share this knowledge with each other. And nobody would hoard solutions to themselves. It's very, very difficult to create an arrangement like this. So it's unlikely that it will be possible. Of course, this is still far into the future. Like, the changes that are happening are quite slow, but it is happening unquestionably. So actually, at the end of last year, just for myself, I did some basic research just to see what percentage of data recovery companies have gone out of business. So what I did is I took my database back in 2015 and I picked random 200 dedicated data recovery companies in the US. So companies who were only doing data recovery and nothing else. So I picked a random 200 companies, and then at the end of 2022, so about 7 years later, I looked up all of these companies. So I manually I researched all of the company names, technicians' names, addresses, everything I could. I tried to look them up on Google, on social media, everywhere, just to see if those companies were still around. And out of 200 companies, only 37 were still in business. So another 163 have gone out of business. So more than 80% have gone out of business between 2015 and 2022. And some of the key reasons for this I already talked about. So it's just getting more and more difficult to do data recovery. More and more cases are unrecoverable. There is a partial shift to solid state drives, which are just much less recoverable than spinning drives. So this means there's less cases overall that are doable. So this is why we focused so heavily into read instability handling, because for us it was always clear for many years now that read instability issues and logical corruption will be the only types of problems that will be possible to handle in the future. And that's why we're focusing on USB stabilizer. And I guess another question that people ask me quite frequently is whether read instability issues will become either impossible to handle or they will disappear in the future. And so the answer to that is no. So read instability issues cannot disappear, simply because this is not a technology problem. It's sort of more like a business problem. So hard drive vendors have had the ability to completely eliminate or almost completely eliminate read instability issues for about 30 years now, or maybe even longer, because the drive itself knows very well, at a very early point, long before it actually shows signs of read instability issues. It's just that instead of notifying the user and just telling the user that they could have a window pop up saying your drive it might fail in a week, you should back up your data. They could do that, but they're choosing not to. So they're going in the opposite direction. So what they're doing is they're taking every possible step to hide the problem from the user. And so at very early stages, the user doesn't even understand that there's a problem, and they only start to understand when the drive can no longer hide the problem, when it's so severe that the storage device is just hanging, or it's so slow that it can't get anywhere, things like that. And this is done for business reasons. So has nothing to do with technology. It's just because if they hide the problem, then they will get the maximum lifetime or perceived lifetime in terms of the user out of this device. And this way they get less warranty replacements, because of course, the later the user realizes there's a problem, the later they will look into sending it in for warranty replacement, and the more money that the manufacturer will save. So this is purely kind of a business problem, and this is why we have read instability issues. So they could eliminate something like 90% of all data loss, and it would cost them very little money. But they're just choosing not to do it because, well, that's how multi-billion-dollar companies work. Yeah, that's why we have read instability issues, and that's why they will always be around. Manufacturers will always push their devices well beyond the point where they should be pushed, and we'll have read instability issues. So yeah, this is something that's forever. I guess that's about all I wanted to say for this first video. Let me know what you think about this kind of informal format. I can cover a lot more content this way because it's extremely time consuming to make professional videos. So we'll see how people like it. I'll make at least one more video on the stabilizer as I've discussed, and from there I'll kind of play it by ear depending on what the response will be. I know some people will probably be upset about some of the things that I've said, so we'll see how it goes, and I'll see you in the next video.